Hello and welcome to section 3.2, day 1. Today we're going to look at graphs of functions. We're going to look at how to graph functions, identify the domain and range, and evaluate functions at an indicated value. Okay. So these are the basic shapes of the functions we're going to graph. A lot of times we call them the parent functions. Okay. So these are all the basic shapes. They're also known as our parent functions. Because we start out with these functions and then we move them. We move them up, down, left, right, but the basic equation is still the same. So the first one is our absolute value function. Remember, absolute value functions have to look like a V. And it's hard to see, it's written here, but y equals the absolute value of x. Okay. The next one is your linear function. We've looked at these already this year. Here it is on a table. Here it is graphically. But notice that at all of these points, this is the point -2, 2, this is 0, 2, this is 2, 2, the y values are all the same. So that is a case where it is y equals 2. Okay, so whenever it's linear and it's horizontal, it's y and then the constant. Y equals whatever number we got going on right here. Okay. The next one is our y equals mx plus b, our linear function. The parent function for this one, it goes through the origin. So your y-intercept is 0 and it has a slope of 1. So it's y equals 1x plus 0. So it's really y equals x. Okay. So it's our linear function. The next one is our good old quadratic. Y equals x squared. Once again, it's written on there as f of x equals x squared. Means the same thing from our last notes, y and f of x. The next one is the reciprocal function. It is also called, it can also be known as a rational. That's an O. And the reason it's called, we got to remember rational is ratio, which means fraction, so 1 over x. And with this function, we have talked about domain, and we know that our denominator cannot equal 0. So graphically, at x equals 0, there is an asymptote, and the curves will never touch it. Okay. And then the last one is our good old square root function. We got f of x equals the square root of x, and it starts at 0, 0. If I plug in 0, square root of 0 is 0, and then we got 1, 1, square root of 4 is 2, and that is what our square root function looks like. So these are all of our basic shapes. So today we're going to be moving functions and graphing them, okay? So they'll have these shapes but be moved left, down, up, right, all that kind of stuff. So graph each by first making a table. You can use your graphing calculator or your brain. So let's make a table for this one. And really, this is just y equals 5, so I wouldn't even say we need to have a table, but it's usually safe for most of them until we get into more complex ones to start out with -2, -1, 0, 1, 2 for our table. And no matter what I plug in here, you're always going to get out 5. Okay, so you could plot these points, but you could also know it's a horizontal line at 5. Okay, so there would be my y equals 5, or f of x equals 5. The next one is our good old linear. Y equals mx plus b. You could make a table once again. You can graph it. Okay, so we know that our y-intercept is -1, and then our m is 2. So we're going to go up 2 to the right 1, up 2 to the right 1. And I really recommend that you cover all of the graph. I mean, you don't have to do all the points, but enough to get you a good start and then draw the line all the way across. In class, ooh, that was not what I was expecting. I was expecting a line. In class or in a test, I always have rulers if you want to borrow a ruler. Okay, so there is part B. So these are both linear. The reason they're linear, they're nice straight lines. So that's example 1. Example 2, we have upped it. These are the absolute value functions. So remember, absolute value functions, okay, should make the shape of a V. Okay, so these are absolute value, my parent function. I don't know where I want to write this. Our parent function is the absolute value of x, which is the V shape. Starts at the origin. It makes the V shape. Okay, so for this one, we always go ahead and look at what's on the inside of the absolute value. And so it's x equals, and you set it equal to 0. Okay, that tells me I'm still going to have a vertex that's x equals 0. Okay, so that means you make your table of values with that being in the very middle of your table. Okay, so 0, and then I would say like 2 below and 2 above. 1, 2. So if I plug in -2 here for f of x, it's the absolute value of x minus 1. So I plug in -2. The absolute value of -2 is positive 2. 2 minus 1 is 1. Okay, now I plug in -1. Absolute value of -1 is positive 1. 1 minus 1 is 0. Okay, plug in 0. It'd be 0 minus 1, so -1. I plug in 1. The absolute value of 1 is always a positive, so it stays 1. 1 minus 1 is 0. And then lastly, I plug in 2. The absolute value of 2 is 2. 2 minus 1 is 1. Then you can plot those. So we got -2, 1, -1, 0, 0, -1, and there that is. And then we would go ahead and graph this. And there it is. It is a V shape. One thing worth noticing, you take what's in the absolute value and set it equal to 0. And then do you guys see how this has a -1? This actually gives you the vertex. Okay, so our vertex was when x was 0, and then the part on the outside is -1. And notice that's the middle of our table, and notice that is our vertex, or the pointy part of the absolute value function. So those are some little tips that can help you graph absolute value functions. Okay, we're going to learn a lot about a lot of different functions, so you're going to have to try and remember how to decipher all of them. But absolute value, you can find the vertex and put that in the middle of the table. So let's actually find the vertex for the next one right away. So we take what's in the absolute value, set it equal to 0. So we will add 3 to the other side, so x is equal to 3. And then what's your y value? So this part came here. This is your y value. So your vertex is 3, -1. So we make and put that in the very middle of our table. 3, -1. So if I plug in numbers less than 3, okay, or think of numbers less than 3, 2 and 1, and then I put in numbers bigger than 3, so 4 and 5. So I plug in 1. 1 minus 3 is -2. The absolute value of -2 is 2. 2 minus 1 is 1. Okay, now I plug in 2. 2 minus 3 is -1. The absolute value of -1 is 1. 1 minus 1 is 0. Plugging in 4. 4 minus 3 is 1. The absolute value of 1 stays positive 1. 1 minus 1 is 0. And then lastly, 5 minus 3 is 2. Absolute value of 2 is 2. 2 minus 1 is 1. Okay, so when you plot those points, we got 1, 1, 2, 0, 3, -1, 4, 0, 5, 1. And notice it should be symmetric, meaning at your vertex, everybody's doing the same thing on the left-hand side as the right-hand side. And you have your V shape. If it ever doesn't come out V shape, replug your numbers in. You're probably just making a silly mistake. But check, this is my vertex, which is 3, -1. And that's what we got there. Okay, so there is part B. All right, example 3, we're moving on. This is a different type of function. My parent function for this one, I'm going to write it this time, over here, is f of x equals x squared, which we all know is our good old parabola, U-shaped. So these should all be U-shaped, but looking a little bit different. So we're going to start out once again. We can plug in -2 to 2. And so when I plug it in, I'm going to write this one out. Maybe here, I'll erase it. So we have f of -2 for this function. We would have -2 parentheses -2 squared. So you got to be careful. It's really -2. You square your -2, which gives you +4, which gives me an answer of -8. So I plug in -8. Then I plug in -1. I have negative 2, then I have negative 1 squared. So negative 1 squared is 1. Negative 2 times 1 is negative 2. Plug in 0, that's straightforward. 0 squared is 0. 0 times negative 2 is 0. I plug in 1, should get out negative 2. Plug in 2, I have 2 squared, which is 4. 4 times negative 2 is negative 8. Okay, so there is that. And now I'm going to go ahead and graph it. What do we got? We got negative 2, negative 8. I think I counted that out right. Yep, okay, negative 2, negative 8. Then I have negative 1, negative 2, and then I have 0, 0, 1, negative 2, 2, negative 8. Okay, and then it should be U-shaped. It's a parabola. Make sure it's U-shaped. If it's not U-shaped, if it looks like a V, you're going to probably lose, you're going to lose points. It's got to be U-shaped. Absolute values are V-shaped. Okay, all right, that is that for that one. Okay, then the next one. You guys have looked at this before, but we're going to go ahead and graph it. And we're going to do the same method here, but one thing I want to point out is vertex form. Okay, this is what the form it is. I could rewrite this as x minus h squared plus k. And just like our absolute values, what's on the inside, if you take and set it equal to 0, that's your x value of your vertex, okay? And this is your y value, okay? So then your vertex would be h comma k. So you'd want to put that in the middle of your table. So for this one, we really have x minus 0 squared, kind of like our circles that we did in Unit 2, plus 3. And if I did my vertex, if I set this equal to 0, I just get 0, so it's 0 comma 3. So that should be the middle of our table, okay? Just so you have an idea. If this was x plus 2, you'd want to have, let's just go ahead and do this. If I had x plus 2 squared minus 7, my vertex, opposite of here, negative 2, and then the same as the outside, negative 7. That would be in the middle of your table, okay? That's how you'd want to center it. But when the x is by itself, you can just start it with 0 and do negative 2 to negative 1. Or sorry, negative 2 to positive 2. So we're going to plug those in. Negative 2, negative 1, 1, 2. So if I plug in negative 2 squared is 4. 4 plus 3 is 7. Negative 1 squared is 1. 1 plus 3 is 4. Plug in 0, I get out 3. Plug in 1, I get out 4. Plug in 2, I get out 7. And then we graph it. I got negative 2, 7. Negative 1, 4, 0, 3, and there we go. And then once again, make sure it is U-shaped and not V-shaped. Okay, so there's our parabola. That is example 3. Questions. Make sure, I don't even know why I'm asking questions. If you have questions, write them down. You can ask me when you see me next. All right, example 4. Graph each by first making a table of values. So for these, the parent function from our very first page is f of x equals the square root of x. Okay? And what helps us come up with our table for this one is the domain. Remember, domain of square roots is you take what's underneath the radical, okay, this part, and say it has to be greater than or equal to 0. Okay, that's the part you want to use. So we are going to go ahead and take what's under our radical here, x, and say it has to be greater than or equal to 0. And that's how we make our table. Okay, we're greater than or equal to 0, so I started out 0, and then what numbers are greater than it? Negative 1, negative 2. Actually, I'm not, why would I say negative 1 and negative 2? I should say positive 1 and 2. So 0. And then I'm going to think about it. I could write down 2, but is the square root of 2 a perfect square? No, so I'm going to move to 4. Okay, and we'll see how that kind of pans out. So if I plug in 0, I really have the square root of 0 minus 3. The square root of 0 is 0. 0 minus 3 is negative 3. Okay, here, square root of 1 is 1. 1 minus 3, negative 2. If I plug in 4, square root of 4 minus 3 equals 2 minus 3, so negative 1. Okay. If I were going to continue with my table, who would be my next best number to plug in? 9, because the square root of 9 is 3. 3 minus 3 is 0. Okay. So when I plot this, I would have 0, negative 3. I have 1, negative 2, 4, negative 1, and then 9, 0. And square roots. They're only for x's greater than 0, so there should be nothing on the left-hand side, and this would be my square root function. Okay. All right, B, moving on. Let's find our domain. Take what's under our radical, x plus 1, and say it's greater than or equal to 0. Solve it. So x has to be greater than or equal to negative 1. So I make my table. I plug in negative 1, and then numbers bigger than negative 1. 0. Let's think about, do I want to plug in 0? 0 plus 1 would be the square root of 1, so that's good. What number would I want to plug in next so I have a perfect square? Well, I want 4, so I'd plug in 3. 3 plus 1 would give me 4, and then I would want 9, so I'm going to plug in 8. Okay. So moving on, I'm going to plug these numbers in. Negative 1 plus 1 is 0. The square root of 0 is 0. 0 times 2 is 0. I plug in 0. 0 plus 1 is 1. The square root of 1 is 1. 1 times 2 is 2. Okay, plug in 3. 3 plus 1 is 4. The square root of 4 is 2. 2 times 2 is 4. I plug in 8. 8 plus 1 is 9. The square root of 9 is 3. 3 times 2 is 6. And then I go ahead and plot my points. I got negative 1, 0. 0, 2. 3, 4. And 8, this should be 6. It kind of looks bad, but. So this is 10, 9, 8. And the biggest thing is square roots only have an arrow going in one direction. If you draw an arrow on both ends, you will lose points. Okay. So there is our square root function graph. So you got to think about the domain. Okay. Then we have our good old rational functions. Same thing here is our domain will help us. Okay. Our parent function is 1 over x. So if you remember, that's the one that has the asymptote. So we're really going to want to find our asymptote to start off with this one. Okay, so our domain. We have x minus 1 cannot be 0. Denominator can't equal 0, so x cannot equal 1. So what this tells me is I have an asymptote at 1. Okay, so then I go over here and I put a dashed line up and down to represent my asymptote. Mine's not perfect, but there it is, at x equals 1. Then I go ahead and make my table centered upon that value. So plug in x and y, put 1 in the middle. Numbers less than 1, 0, negative 1. Numbers bigger, 2, 3. If I plug in 1, 1 minus 1 is 0. 1 divided by 0 is undefined. Okay, so that's what we have on our table. Then I go ahead and I plug in these other numbers. Negative 1 minus 1 is negative 2. 1 divided by negative 2 is negative 1/2. Plug in 0. 0 minus 1 is negative 1. 1 divided by negative 1 is negative 1. Then I move on to 2. 2 minus 1 is 1. 1 divided by 1 is 1. And 3 minus 1 is 2. 1 divided by 2 is 1/2. So I will graph this. Okay, so I got negative 1, negative 1/2. It's kind of hard. My graph's kind of small. And then I got 0, negative 1 here. So we know we have to get close to our asymptote. So we're getting really close, but you're never actually touching that line. Okay, and we know from our parent function that this is going to continue this way and get really close to that axis. Mine is not drawn very well. Okay, really close. Then we go ahead and we have our undefined, then we plot, 2, 1, and 3, 1/2. So it's going to get really close again to your asymptote and then really close to this axis right here. Okay, so the rational functions have these two parts, okay, across from each other. The next one we're going to graph, same idea. We take our denominator, set it equal to 0. So, sorry, domain is that x cannot equal negative 2. So that means we have an asymptote at negative 2. I'm just going to freehand this one. Hopefully it goes okay. Dash line, always do a dash line. So x equals -2. And then we also go ahead and make our table. It is centered at -2. Remember, if I plug in -2, -2 plus 2 is 0. So I have 1 divided by 0, which is undefined. Then I would have -3, -4, and then I would have -1, 0. And I would plug these points in. -4 plus 2 is -2. 1 divided by -2 is -1/2. If I plug in -3, -3 plus 2 is -1. 1 divided by -1 is -1. Plug in -1. -1 plus 2 is 1. 1 divided by 1 is 1. And then if I plug in 0, I get 1/2. So I plot -4, -1/2, -3, -1. Okay, and you would see, once again, these are on this side, so we're going to get really close to our asymptote and really close right here. And that is it. Then I have -1, 1, and 0, 1/2. Oops, I got. And we draw it so it gets close to our asymptote, doesn't touch it. So the asymptotes are there. We get really close but never touch, and then we go that way. So there is our rational function or reciprocal function. Okay, both names are good. All right. Now, the next thing we have to do is we need to look at some graphs and go ahead and find values on it, okay? So this is different. Usually you guys are given an equation for f of x, and then you need to go ahead and find when f is -4. Now we're actually given the graph, and I don't have the actual equation, so we have to use the graph. So what this means is it's usually f of x, and we look for the y value, okay? So we plug in -4. If I go to my graph where x is -4, and I go up, okay? What is my y value? So maybe we want to make a note. So when x is -4, y equals question mark. That's what we're trying to find. So if I go here, do you guys see how it's an open circle? That means there is no y value. And I look all the way up and all the way down, and I don't see any closed circles. So in this case, actually, there is no y value. So we say it does not exist. And to shorten things up, we usually write D and E in capitals, okay? So that's what f of -4 is. Now let's go and find f of 1. So this is really saying when x is 1, what is my y value? Okay, so I'm going where x is 1. Looking up and down. Oh man, I got two options. This one is closed and this one's open. Open means it's not there. Okay, so we are not taking this one into account for my point. We're looking where the closed circle is. So here it is. It's where x is 1. What's my y? 4. So f of 1 is equal to 4. Now we need to go ahead and find f of 6. So when x is 6, what's my y value? So I'm looking, open circle, that's not what I'm looking for. I'm looking for the closed circle. My y value is 2. So this one is equal to 2. Okay, so that's how you find values off of your table. Okay. Then we just need to remind ourselves about domain and range from a graph. Okay, we got our parabola, which we know is something of the form, the parent function is y equals x squared. Is there any problems with this in terms of domain for x squared? No, but we can also look at it visually. Our domain. Remember, we always look left, then right. Okay, so if I look to the left, those are going to continue on. Those arrows tell me they're going to continue on. And if I look right, same thing. So it's going to cover everything. So it's all real numbers, or if we want to do it in an interval notation, which is kind of how you move to in calculus, it's really negative infinity to infinity. It's going to go all the way to the left and all the way to the right. Okay. Then we also need to go ahead and find range this time. So remember, our range is our y values. So that's where you look down and then up. Okay, so down and then up. So I'm looking down and I see that this is my smallest y value. And then it's going to go up. So it is all y values. Whoops, that's a bad curly bracket. All y values such that y is greater than or equal to 2. That's option 1. Or we can do interval notation. So my lowest y value is -2. Or sorry, not -2. Where did I get? I was looking at my x, but I was thinking about my y's. Oof. So this is -1. That's my y value. My x value is 2. We are talking about range to y values, so it should have been -1. My bad. All right, let's put in interval notation then. My lowest number is -1, so bracket -1 because it's included. And you see how it's going to go up and up and up to infinity? So it's -1 to infinity. So there is that one for domain and range. B doesn't have arrows on it, but it should. Okay. In your textbook, they'll be sure to make it a closed circle so you know it's an endpoint. So if they don't have arrows on and it looks like this, you can go ahead and add them on. So my domain, we look left and then we look right. Is this going to continue to go to the left forever and ever? Yes. Is it going to continue to go to the right? Yes. So it's everything. So -infinity to infinity. My range, my y values, we look down and then we look up. So down, this is going to continue to go all the way down, and then it's going to continue to go all the way up. So my range is -infinity to infinity. So it's all reals for both of them. Okay. All right, 2 more, and then we're going to call it a quits for today. Okay, we got this, which should be closed circle here. I'm telling you it should be closed. I want it to be closed. And closed circle here. Okay, so my domain, we look to the left and then we look to the right. Okay, looking to the left, this is closed, so I'm going to include it, which is an x value of -2. So bracket -2. Then I go ahead and I follow this. I'm including every value, but I see this weird thing here. But you guys see how 2 is included here but not here? That's what makes it a function, keeps it a function, right? We're only touching one point at a time. And since it's not included here, but included here, we still continue on, right? So our domain includes everybody, then we continue here, all the way up until 5. And it's closed circle, so bracket. Okay. Then my range. We look down and then up. So down, my lowest y value is -2. And then I see that this is at a y value of 1, but then you see how this one picks up and we continue going up all the way until, I would say this is probably 6. So 6, bracket. Okay, so there's that one. And then lastly, D, my domain, it's a line. Is there any problems with lines plugging numbers in? Y equals mx plus b. You can plug in whatever you want. You'll always get an answer out. So we can go all the way to the left, all the way to the right. So it's all reals, or -infinity to infinity. Is it going to go all the way down and all the way up? Yes, so -infinity to infinity. Okay. So that is example 7. That is our graphs of functions. Okay. Your homework is 2 through 16 evens, 23 and 24. So 2 through 16 are graphing like we did today. You can either sketch the graphs if you want, or if you want to grab coordinate planes off of the internet and put them on your Notability and just do the graphing on your iPad. That sounds good. Otherwise, you can freehand sketch it, or if you have graph paper, that's even better. So there is your homework. If you have questions, feel free to message me. Otherwise, I will see you in class. Take care.